A very good afternoon to all of you. I'm Ankita Chauhan from NASSCOM Product Council, and I'm back with the eighth episode of our data science series. And today's topic is very interesting as it revolves around AI-led transformations, some relevant case studies. I have with me Prashant Joshi, who is fellow and head artificial intelligence and machine learning and fractal analytics, who will share his knowledge on this very interesting topic. Before I hand over to Prashant, I have two more things to say. Ask questions anytime during the session. Prashant will cater to most of them during the end of the webinar. Second, please leave your valuable feedback so that it will help us in improving our future sessions. Over to you, Prashant.
Thanks, Ankita, and hello, everyone. And I would like to thank Ankita and NASSCOM for organizing this fascinating series of conversations. So, what I'm going to do today is I'm going to take all of you through a about 40-45 minutes long session. And I'm going to take you through how AI, machine learning, predictive analytics is being used in the business world today to make different kinds of transformations, how we can leverage the huge amount of data that is being generated. So AI and machine learning, and I remember it's not too far back in time, about 15 years ago, was something that you only used to discuss in academia and in those labs out there. But now it has become more and more mainstream. And this is one of the examples, a very recent example. So Google, when it acquired DeepMind, and DeepMind is the same company which invented this AlphaGo, the algorithm that could beat the world champion in the board game Go. So DeepMind was known not only for designing those games, but essentially the one value add that it had was it applied the deep learning methodologies to Google's own computing servers. And when it went there and applied deep learning to the server farm and the data it was generating, it could figure out a better way to handle or to manage those server farms, which led to about 40% reduction in the data center cooling bill. It is an enormous feat because Google is consuming about 0.5% of the entire world's electricity. So imagine the kind of transformation that algorithms can bring about or machine learning can bring about. And recently, what I know is about a month ago, what I heard was Google has completely handed over the server farm management to DeepMind and algorithms. So now everything is completely automated and it leads to a huge amount of saving in the energy bill for Google. And we can look at it from this perspective, right? These kinds of innovative use of algorithms are pretty much possible in every single realm of industry. Let's take a look at a few more of them. And this one, in this particular anecdote that I'm going to discuss now, happened in University of California, San Francisco. And what happened there was a couple of years ago, in the university hospital's pharmacy, there was a prescription which was wrongfully delivered. So essentially, the pharmacist made a human error and delivered the prescription of a medicine which was different than what it was supposed to be, which led to one death. Overall, around the world, there are about 7,000 deaths happening due to wrongful delivery of prescription. So what happened eventually was UCSF, University of California, San Francisco, decided that they will do away with the need of pharmacists in their pharmacies. Let me categorize that statement a bit further. It's not that they're going to completely remove the pharmacist, but they're going to figure out a way to use algorithms and robotics so that the pharmacists are used for what they do the best. That is to advise the patients on how to consume medicines, what are the side effects, what are the things you can eat with them, or what are the things they can interact with. So what to do, what not to do when you're taking certain medication. So that's the role that the pharmacist can do the best. And the actual mixing of drugs and the delivery of drugs was then handed over to a robot, which you see in this image. And as of now, the entire university pharmacy is completely robot driven, and the pharmacists over there are simply being simply delivering advice to the patients. The other thing that I would like to mention is, I mean, see, data science, algorithms, machine learning, AI, all of this is very fancy, very powerful. But finally, all the algorithms can do, I mean, algorithms are still basically gonna do what you instruct them to do. So, what kind of problems you can solve depends entirely on your imagination of what data is being generated and how can you leverage that data to solve a new problem. So it's still us as data scientists or stakeholders who have to define what are the different interesting business problems that we can solve using the data that's being generated, that the data that is available to us. To to make a case in that direction, if you look at this image, it's an image of a parking lot from pretty much, I mean, such a image or aerial snapshot of a parking lot. Now, what I found as a very interesting insight when I read this case study was images like this, images of parking lots, are being used by venture capitalists to figure out how good a business is doing. For example, if you take a look at this snapshot, and if it's a snapshot of a Walmart somewhere in the Midwest of US, you can figure out how good that Walmart is doing in terms of the business. And depending on the time of the day and the number of cars in the parking lot and the models of the car, you can make a lot of projections. So what you have now discovered is a new data source that you can leverage to get some more insights which you can use to for getting better results for a particular business problem. So all of this, I mean, so these are just three teaser studies that I mentioned, which are very innovative in the use of data, and they were solving some very significant big value problems. And all of this is possible because now there are two factors that have come in. One thing is we are generating data at a humongous pace, at an exponential pace, and this data is now called as the big data. And the second thing is, I mean, not only that the data is being generated at an enormous pace, but now we do have the computational power to actually play around with this data at that petabyte scale and generate insights which can be uh, of use. So big data, or this new data is the new gold rush. So to collect this data, all the corporate world, all the industries, governments are running around and trying to figure out and set up infrastructure that can capture this data in a way that it can be leveraged by algorithms. So this is the new natural resource in a sense. And what it has brought about, another big revolutionary change that has come about is the access to this very valuable data sources and the ability of the algorithms to work at the scale on this data has allowed us to move away from making decisions based on gut feeling or experience or or our priors to more data driven decisions. So in fact, the quotation that you see on the screen right now, in God we trust, all others must bring data, is something that I stand by. So the idea is essentially to answer a question in a more quantitative, more objective fashion, you need to rely on the data that's available to you and figure out sufficiently sophisticated techniques to manipulate and leverage that data in order to get the answers that you require. So here's a snapshot of the amount of data that is generated on a daily basis. So there are about 75 million Instagram posts that are happening on a day. There are about 900 million posts to Facebook per day, roughly a billion. 7 billion mobile devices in use across the world, 11 billion internet connected things, which again is a huge rich source of data. Then there are about 17 billion US dollar worth of credit card transactions happening in a day, and about $3.7 trillion worth of transactions overall happening in a day. I mean, see, all these numbers, what they are showing here is we are really generating data at a enormous and exponential pace. And all this data that we are generating, we are still trying to play catch up in terms of how we can leverage this enormous data in real time and deliver meaningful insights and results. So we are still working on using data at so big data using big data with machine learning algorithms is happening as of now. Using big data with machine learning algorithms and delivering predictions in real time is still a challenge that we're still working on. So the space at which the data generation is growing is about 60% annual growth rate. So year on year, there's a 60% increase in the amount of data that is being generated, with most of this data being of unstructured data format, that is the data in the form of text, video, or audio. And there's still about 20% of data that's generated still the structured old tables and columns. So if you look at these numbers here, so as of now, it says that in 2015, we had about 8 zettabyte of data, that the digital universe was of the size of 8 zettabyte, whereas 1 zettabyte is about 15.6 million smartphones worth of data, which is, so just to give you some comparisons, there are about 300 million smartphones in India. So the amount of data that exists in this digital universe overall is humongous in nature, and we still have to figure out ways to leverage it in a meaningful fashion. So with that preamble, I mean, the question that we are going to try to figure out in the rest of the conversation is how to uncover the potential of this enormous amount of data that is being generated on a daily basis, and what can we do as data scientists. And to answer that question, what I'm going to do is I'm going to take you right there and show you three or four relevant case studies, depending on how much time we have, of very innovative ways in which companies have been leveraging the data that is available to them or that they are currently generating to solve very, very unique, innovative problems in business. So I'll cover a couple of case studies where the focus is on unstructured data, and then given time, we'll go ahead and look at some predictive maintenance case studies. So the first case study that I'm going to talk about is so it's about sensitivity text analytics using AI and machine learning methods to find certain segments for sensitivity. So what happens here is the patients who suffer from dental sensitivity. So based on the market research done and these, by the way, all these four case studies are from work that has been done in Fractal in my group. So these are the case studies where we own the data and we have delivered the solution. So in this first case study, this was done for our client who is one of the top 5 CPG world. And what our client did was they did a very interesting market research study. And the outcome of the study was they figured out about 60% of folks who suffer from dental sensitivity, they do not go to a dentist to solve their problem. So on the other hand, what they do is they just go ahead and buy one of the popular anti-sensitivity toothpaste. So essentially, the 60% of consumers who have dental sensitivity, they are already very loyal to a brand out there. And it's what they realize as a part, another part of this market research study is that it's extremely hard to penetrate into the 60% segment, the segment that will automatically go and buy that particular anti-sensitivity dental toothpaste, which incidentally was owned by the competitor of our client. So what they realized, this was the start of a discussion between Fractal and the client, where what we realized is it might be easier to identify the remaining 40%. The 40% of customers who actually are not going and buying off the shelf anti-sensitivity toothpaste. So how do you go about doing that? So the insight was, why don't we look at what all people are talking about in social media when they talk about different issues related to dental hygiene, dental health, or dental products. So, so with that in mind, what was done is to look at a lot of product reviews that was made available to us, and then essentially figure out if we can use NLP techniques to separate customers into different segments which belong to customers who are loyal to one of the competitor brands, and segment of customers who can be handled differently. And to do that, what was done was we started with this corpus of customer reviews. These are the reviews in Amazon. And then we had a master list of dental topics that were given to us or that was created in conjunction or in collaboration with. And what you did is then you went ahead and took a look. Then you had another data source, which is essentially made up of two constituent data sources. One is DBpedia, which is the tech stack for Wikipedia. The other was about 39 or 40,000 dental journals. So journals that discuss, so these are the medical journals that discuss different dental issues. So if you talk about it in an abstract way, the way we went about was to use the NLP techniques and along with the master dental list and the reviews to first of all enrich this list of topics. And then what you do is you do topic modeling on the reviews as well as DBpedia stack and the dental journals. And based on that, now you're trying to figure out which are the topics that were extracted that were found in dental journals, in DBpedia, and also in reviews. So if a topic exists everywhere, then this is the set of topics that are being used uh, trivially or that are being used uh, in a more common sense. But if a topic exists in not all these sources, so these might be novel or unique ways topics that have a huge correlation to dental sensitivity. And let me take you through the results that came out. Or just before that, the kind of data that we consume. So this problem, to solve this problem, we consumed about 100 GB worth of reviews. So if it's a simple text dump of reviews, that's a humongous amount of reviews that were crunched, along with 39,000 journal articles, and all this data was analyzed and processed in about 2 weeks of time. And this is the results that you see of this analysis. What you see here is on the left hand side, you see the various data sources that exist. So we use some reviews from Amazon and Walmart. These were the predominant data sources. Then we also had some tweets that were made available to us, but this was only during the initial proof of concept. In the productionization of system, this proved to be a bit of a problem. Nevertheless, given that these are the reviews of products, we also have these additional augmented data sources, which are market research reports, then consumer affairs data, and the dental journals data. Based on that, what Fractal has is a proprietary suite of NLP algorithms, which we call as Decrypt, which include different things like topic modeling or sentiment analysis. We use Decrypt in order to extract various topics that were available in these reviews, as well as the dental journal text, as well as the market research reports. And then we ranked them based on known topics. So known topics are the topics that we actually are not going to be interested in, as well as fringe topics. So what you find here is, if you look at the scorecard, so for each of them, we have, so these are some of the topics that came out. We had mouthwash as a topic, then we had oral surgeon, tooth pain, mouth guard. All these topics came out from this customer reviews. And then once we cross-tabulated it with the journal articles, we're able to rank these topics according to our interest, which is we want to find non-trivial and non-obvious topics that have a high correlation with dental sensitivity. So, for example, one of the things that came out and which was a pretty surprising, although correct result was we found chemotherapy as a topic that's popping up very frequently. And chemotherapy turned out to have a very high correlation with dental sensitivity. So that is, if a patient is undergoing chemotherapy, you have a high chance that the patient would also suffer from dental sensitivity. So essentially, this gave us a way to reach out to different segments of customer And the idea would then be to create, for example, very targeted marketing campaign or to design products that are very specifically designed for a particular customer segment in order to, be able to better serve the market. So that's one case study which I found to be very innovative in the sense that we started with the premise that I want to reach out to people who suffer from dental sensitivity but do nothing about it. Then the next thing is, how do I identify those customers? And the idea would be, let's see what they are talking about and try to figure out if there's a correlation between what they talk about and dental sensitivity through topics that are not obvious. And in that stream of thought led to this case study, and this has been productionized as of now and is extremely successful. Let's move on to the next case study, which is again a very interesting one. So here again, this case study is about predicting the outcome of a research and development experiment, and this case study was done by Fractal for one of the top five CPG companies in the world, so big five. And here the idea is, whenever a CPG company is trying to launch a new product, it could be, for example, like toothpaste, or it could be, I don't know, a hair gel or something or other. What has to be done is, and these are the basic, I would call as the legal and health requirements, or the sanity check or sanitization requirement, that the company will have to run that newly designed product through a battery of experiments, and these are the actual experiments you do in the chemistry lab. So for example, how good the quality remains as you change the temperature, or what is the freezing point of the product, or is the product when the what is the shelf life of a product. I mean, bunch of different ones. So in fact, the R&D group of a CPG company, to launch a single product, has to run about 400,000 stability tests a year. No, sorry, 400,000 stability tests are run across all products, and these tests, I mean, so these are standard tests. So now the idea is, what happens, or the pain point of the businesses, from the moment when you think of a particular product to the moment of its design of the product, and then running it through these tests. These tests take about 8 to 13 weeks to run for a single product. Sometimes by the time you finish all those tests, and even if the tests show a very positive result that this is a fantastic product, you might be too late. You might be too late to enter the market because your competitor might have beaten you, or simply the product has phased out. So now the idea was, we agreed that we have to run these n number of different R&D tests on this product, but can we now figure out in a more or less deterministic fashion the outcome of these experiments? So, for example, if I have to figure out what is the freezing point, or like how what is the let's say, when is my product gonna what is the shelf life of a product? Let's say what is the shelf life of a product, given that I am keeping this product in a temperature range of 40 to 55 degrees centigrade. Now, if I can deterministically determine the outcome of this experiment, then the idea is I do not have to run this experiment. So this was the premise of this case study. Given that I know the set of experiments that have to be run, given that I have a historical data of all the experiments that ran on a bunch of different products, can I now figure out the subset of experiments where I can algorithmically predict the outcome of that experiment, given that I know the experimental condition, given that I know the different chemicals that have to be part of that experiment, what would be the outcome? So here, to solve this problem, what we did was, we had all these lab reports, which are again based on, these are like a typical pathology report. It's an experimental report. So what we did is we used OCR along with different text extraction techniques in order to consume these lab reports and create our input feature vector. And then we tried different machine learning algorithms in order to predict the outcome of an experiment. And net, what we were able to do was we were able to identify 53 different experiments that have a minimum failure risk. So essentially, for those experiments, we are guaranteed to predict the outcome in a more or less 100% sense. And this is about a 12% reduction in the overall testing volume for that particular product. And that's a huge reduction. So your 8 to 13 weeks of time shrinks down by about 12%. Right. And what finally worked here, and here you see a couple of different things on the slide. So if you look at the right hand side, you have this simulated prediction plots. So you have two different experiments that are happening. So you have soluble fluoride on the y-axis, which is the concentration of soluble fluoride in that particular experimental setup. And what is the age of recipe, number of days is the x-axis. So, and these two, along with the third dimension, which is mentioned on the top, which is the temperature and relative humidity. So, what you see is that in this condition, which is shown on the top right, extreme right, that at about 40 degrees centigrade and 70% relative humidity, your algorithms are able to predict the outcome of this experiment more or less flawlessly. Whereas at 25 degrees centigrade and 60% relative humidity, your algorithms and the actual results deviate from each other. So having looked at these two things, what you can simply say is, let's do away with doing the experiments on 40 degrees centigrade, 70% relative humidity, because that's where we simply know the outcome. We only need to ensure that we run the experiment for 25 degrees centigrade and 60% relative humidity. So the way it worked was we used bunch of different algorithms from very simple vanilla regression to random forest to support vector machine and gradient boosting machine. And on the bottom of the slide, you see the results of these individual algorithms on the raw data set. So the x-axis shows the performance measure, which is MAPE, and the lower the MAPE, the better the algorithm is. So, and then on the top left, you see the variable importance result from using random forests. So, having shown all of this, finally, what the production model was then an ensemble of these four models, which gave the best performance. So again, now here what you have done is, so why I chose this case study was, again, we are now trying to remove the repetitive nature of certain experiments or trying to do away with the need of doing certain experiments which are repetitive in nature, and again, where we are reliably able to predict the outcome of those experiments. So essentially, we are making the job of a chemist or an experimenter much more easier, much more unique and interesting, and automating the experiments which can simply be predicted. So let me see how I am doing time wise. I think I have about 15 minutes more. So let's try to look at Ankita, I do have 15 minutes more, right?
Yeah, Prashant, I just also have one request. Your microphone is going far and close from so there is some voice modulation. Somewhere it's coming very clear and then it's just going very far off.
Got it. Is it better now?
Yeah, it's perfectly fine right now, but sometimes within 5 minutes or so, it's just going, coming from far off.
All right. I think it's just because I was walking around and talking. Anyways, I'll
Okay.
stick close to the microphone.
Yep.
Okay, so let's move ahead and look at the next case study. Again, this is using AI-based NLP engine for social listening. And here the context was, so again, there's a lot of data available in social media, all these Facebook posts, these tweets, the blog posts that is available for free to everybody and can be used in multiple different unique and innovative fashions. And this case study is trying, so what I'm going to try to do is to show you one possibility of what can be done with this data, which has been done in this case study. So what we ended up doing was to look at, so or let me first tell you how the problems came to us. So our client, again, a CPG major, they are one of the biggest manufacturers of baby diapers. And they have about five different competitors who also manufacture baby diapers, and all of them are very well known. So there are a total of six different brands of baby diapers that exist in this particular market. Now, what the client had was the following requirement. I want to measure my product against my competitors and see how these products are doing based on what people are talking about them in the social media. Now, if you start with this question, so it's a very easy thing to do, because then you simply have to take a set of reviews or set of social media posts and do topic modeling, and then see, not sorry, topic modeling, do sentiment analysis and see how what are the prevalent sentiments around your brand versus your competitor. But there was a twist, and the twist was the client wanted not only to know how they are doing vis-a-vis their competitors, but they wanted to know how they are doing vis-a-vis their competitors across 22 different attributes that were of interest. And these attributes in the context of baby diapers were, for example, absorptionness of a diaper is one of the attributes. Leakiness of a diaper is on the attribute. Sustainability, and then rashiness. I mean, all these were different attributes that were of interest. So now, with that twist, it became an extremely hard problem to solve. Given that now you have to, so your universe, your computational universe changed. You moved away from doing pure vanilla sentiment analysis to something that's called as aspect-based sentiment analysis. So there were these 22 aspects around which you have to do sentiment analysis of each and every review that comes across. So for a particular review, you will have to look at which of these six brands were present and which of these 22 attributes were present and what was the sentiment around each of those 22 attributes. So again, the next challenge in this problem is, of course, if you compare two different attributes, let's say absorption and leakage. Absorption, having a positive sentiment around absorption is a great thing. Having a positive sentiment around leakage is a very bad thing, because of the connotation of these two different words. Right. So net this made this to be a very interesting data science problem that had to be solved. And the vision here was, so when we started on this product is we were able, what we want to do is end up creating a data science platform, or a set of algorithm that can use product reviews on social media posts for enhancing the product experience, or to access the brand equity in the market, or to understand consumers' perception of our brand versus vis-a-vis competition, or to get even early trends on consumer attitudes, needs, product experience, etc. So the way to do this was to create a NLP-based backend engine along with a scalable architecture, and finally create a front-end consumption layer that can be used to gather insights from the backend data. And I won't take you through most of this, but these are the kind of questions that we are now able to answer. So again, I'll reiterate, the data that we had for this problem constituted of two main sources. One source was the product reviews available for this host of uh, product reviews related to baby diapers. Then the second source was a set of tweets that were available, which had a certain set of hashtags. And when we work with this data set, the kind of question that we could answer was, for example, which is the most popular brand, or I want product feedback, or what is the chatter on my advertising? What are people talking about? Which brands are trending in the same time? So all these questions can be answered using this kind of backend data. So the kind of answers that we were able to extract from these data sources was, for example, is sustainability a concern for users in Sweden? The answer is yes, by the way. Yes, it is. Or what is the product feedback on the new product that we have launched? Or what are the current emerging trends in skincare? Has the new advertising created buzz in UK? So essentially, once you have that back-end data and the set of algorithmic pipeline set up along with your front-end consumption layer, you can get very creative around what kind of questions you want to uh, tackle or get answers for. So this was the approach that we took. So we use set of big data engineering techniques in order to consume the data via the Kafka pipeline. Then the cleaning and pre-processing was pretty standard pre-processing techniques from text mining, and then text was normalized. This pre-processed text, so not, it's pretty vanilla pre-processing, nothing very fancy, like standard stuff. Then we tried to do we built three different models. And when I say category, then what here it means are the different attributes. So like absorption, leakage. So we had to build a model, or we built a model to predict what are the different categories that are present in a particular review or tweet. Then second was brand prediction, which was slightly more sophisticated than simply lookup. So there are six brands. So one thing is, the obvious thing to do is to create simple text lookup of those different brand names. But then there's also ways to figure out through, again, graph based approaches of different ways that the brands can also be mentioned along, not only in the way in the absolute correct brand name works, but there might be nicknames. So we figured all that out. So that was the brand model. And then the third thing was, once you have predicted the categories, various categories and the brands available in a particular review, next thing was to build a model around sentiment prediction across each of these category brands, and which was finally pushed to the consumption layer. Now, I'll show you an example of how good this system worked. So what you see here is two different tweets, and these are real world tweets. So again, remember this is about baby diapers as being this and topic of discussion. The first tweet is great news. At 22 weeks pregnant with my first, you suddenly see situations and adverts like Pampers in a different way, sending you best wishes. So, given that this tweet is the input to our social listening algorithm, what came out was our algorithm has predicted that the brand that is being mentioned in this particular tweet is Pampers, and the attributes that are mentioned in this tweet are three different attributes. One is new mom, one is satisfaction, and one is advertising. So these were the three attributes that were present in this tweet. And the sentiment around the new mom attribute for Pampers is neutral. The sentiment around satisfaction for Pampers is positive, and the sentiment around advertising related to Pampers is positive in this particular tweet. Similarly, now let's look at the second tweet, which is Pampers do a Prem baby ad, which is for premature baby. So free nappies while in hospital. I bet if you or Dean contacted them. So for this particular tweet, the algorithm gave the following results: that the brand mentioned is Pampers, along with these three attributes. One is hospital, one is customer service, and one is advertising. And the sentiment around hospital and customer service is neutral, while the sentiment around advertising is positive. Now, if you take a look at the tweet, even to me, this the last prediction, which is Pampers advertising positive, seems to be incorrect. And the thing is, while the algorithm predicted this, fortunately, we also have domain experts that were able to point that out so that we could fix that mistake in the next iteration of the algorithm. So essentially, again, this has been able to do aspect-based sentiment analysis with about 70 to 73% accuracy, which is a huge thing. given that aspect-based sentiment analysis is one of the cutting-edge things in NLP research. So, all right. Ankita, do we have time for one more case study?
Uh, uh, what is the duration like? How many more minutes, Prashant, will you be taking for that case study?
I think I would need about 10 minutes at the minimum.
Okay, then can you just shorten it for 5 minutes so that we can have some time for. Okay, let's go ahead.
All right, all right.
Okay,
So
okay.
the reason I want to cover this case studies is the first three case studies dealt with unstructured data or text data. I wanted to, toss in a different kind of case study for a change, and which again, uh, what I'm going to talk about is predictive maintenance. So, given that predictive maintenance is about 10 billion US dollar industry as of now, supposedly to grow to 22 billion by 2023. So, this case study is of massive interest. So what we did here was, again, here our client was one of the biggest railway components and rail coaches manufacturer in Europe. So what client realized is, so these they are building these railway coaches, right? And these coaches run across Europe in different climatic conditions from sub-zero temperatures. And what they realize is that the component that fails the most often, and that's not a surprise, right, is the door of a train. And the maximum delays that happen in train schedules is because the door got stuck of a particular train. So now the idea is that, again, can we use algorithmic techniques along with the data being generated by the sensors attached to the train coaches in different places to figure out various set of event sequences that can be an early predictor of an upcoming failure. So with that kind of premise, what we realize is that if we are able to successfully build predictive maintenance based algorithms, then we can eliminate almost 3 out of 4 breakdowns and reduce maintenance cost by about 20%, which is again a huge number, right? So we what we wanted to do was to create, test, and optionalize smart predictive algorithms within our client's data. Now, the data that came to us was from one fleet of the client during the initial proof of concept. And now, for a particular train door, there are 8 different sensors that are attached to this door that are sending the data in. Now, based on that, our idea is to figure out algorithmically what we can do around this. And I'm going to take you through the slide very quickly and show you how this maintenance of train coaches happens as of now across the world, and what is being done differently. As of now, what is already existing, at least in Europe and US, is we have different sensors connected to various components of the train, and the sensor data is continuously being collected. But then post that, we are still doing things in a bit old-fashioned way, which is we have a certain set of rules, or business-driven rules or domain experts-driven rules, which we use to figure out different alerts or rule-based alerts or triggers. And if those triggers are fired, then the engineers or the operational analytics folks go ahead and send the train coach for maintenance. So it's pretty much very static system where you have a certain set of predefined rules to handle that the event data. So instead of that, what was done differently is, now I have all this data flowing to me in real time. Can I create algorithm that can machine learning based algorithm that can predict the upcoming failure? What kind of failure is gonna be? Point one. Point two is, when is it gonna happen? So the type of failure and when the failure is gonna happen. So this is what has been done differently here. And what we found was that there are a bunch of different things that happened. One thing is co-occurrence, which is like certain kind of events will always occur together. So event A will always be followed by event B within a certain amount of time. So they can be considered as a single event. Second thing is, surprisingly, and this was all of us were very surprised, the environment variables and reading can be forecasted for this particular data set to a very reasonable degree. Then the events that we found, and this I think is pretty logical, are directionally dependent on each other. For example, door failure will so door failure will always follow door opening. So door on opening a door fails. Makes sense. Or certain events are triggered only in certain environmental conditions. For example, a door jams when the temperature is below 20 degrees centigrade, minus 20 degrees centigrade. So these are the different insights we found. But then the two problems that we solved. First problem was, what is the next event that will occur based on the historical pattern that we observed? So again, you want to predict. So what we did is we took the set of event sequence and now we have to predict the type of event. So it's a we tried a bunch of different things, including neural networks, support vector machines, hidden Markov models, and sequence association mining. And finally, we benchmarked all of this using F1 score, precision, and recall. Whereas for the second thing, which is given that I know which event is going to happen, when is that going to happen? So this is a time series forecasting kind of problem. And here we use Markov chain distribution of time versus event occurrence and noise reduction of high frequency events. So in this case study, so the outcome of this case study was we were extremely successful with the data of one fleet to the extent that we finally extended this solution to about 8 fleets of data, which is more than 1 terabyte of data. And now we have a running system where these algorithms are in real time handling the event flow data and generating various alerts, which are then being reviewed by fleet engineers. So with these 4 case studies, I'll come to a close of this conversation. And what I wanted to bring as a key message is, while the algorithms have now reached a level of maturity and they are extremely powerful, each of these case studies also brings another aspect into picture, which is that we need to be very creative and innovative around the data that we have access to so that we can figure out various problems of interest that can be solved using AI and machine learning. So that would be about it. Thank you. Happy to take any questions.
Prashant? Yep, let's move on to our Q&A sessions. So the first question is by Aarti. She's asking, hi, in case of you consider Amazon reviews for dental, 40% customer-based review, then how do you remove fake reviews present in Amazon using NLP?
I'm sorry, I could not get the question. Can you repeat that?
She's saying, in case you consider Amazon reviews for dental, 40% customer-based reviews, then how do you remove fake reviews present in Amazon using NLP?
So the removing the fake reviews was not under the scope of this particular study. So the reviews we got were pretty sanitized. When we are building our data, so I mean, fortunately in this case, the data set that we had was pretty sanitized data set, and we did not have to go through the process of removing fake or spurious or duplicate reviews.
All right. The next question is, social listening tools could be used to measure the attributes of diapers.
That is correct. Yes. Even I was surprised, but yes, they can be. So essentially, what you need to do, and again, here the idea is you can pose any problem. So for example, let's say we replace diapers by cell phones. So what you need to do is you need to figure out the subset of social media data. So like of the billions of tweets happening in a day, you create a certain set of hashtags and filter those tweets out to only restrict the scope of your data set to tweets that will have some sort of relationship to what you're asking. For example, in the case of baby diapers, you would start with, I don't know, about 50 to 100 hashtags that you would use to identify if the tweet has something to do with baby diapers or not at all.
All right. The next question is by Abhishek, who's asking how category prediction and brand prediction has been filtered out with best practices.
I'm sorry, I didn't get that one.
Shall I repeat the question?
Yes, yes.
How category prediction and brand prediction has been filtered out with best practices.
So, Abhishek, I'm not sure what you mean by this question when you say filtered out with best practices. So, I'm sorry, I'll have to pass this question because I'm not sure what is.
Not an issue, Prashant. Let's move ahead onto a different question. Um, okay, again with social listening. With your social listening algorithm, the second interview didn't exactly interpret as positive sentiment. What are key parameters used to categorize the sentiment as positive or negative or neutral?
So again, I mean, as in typical sentiment analysis, you start with a set of seed words, and then you work on that. And see, there's no clear which sentiment is positive, which is negative, which is neutral ever, right? But you start with creating a training data set where humans and you what you in our case, what we did was we used five different human taggers, so the people who will tag the data set to on the sentiment around each of these aspects, and we took the majority vote just to make. And this is a standard protocol that is followed even in academia when you build these studies. You take a majority vote of human followers around a particular attribute and a sentiment. The idea is that most people think something is positive, it is positive. Most people think something is negative, it is negative. Given that the some of these attributes will be subject.
All right, Prashant. The next question is by Amit, who's saying in slide 24, you have considered neutral for new mom as positive outcome, whereas it is clearly a failure. Why?
Again, that's a good question, and this led to a lot of hot discussion internally too. See, and this is where let me take you through a small detour of so when we are building this data set. So our subject matter experts at Fractal, including people who have been in CPG domain for more than 20 years, they thought that new mom has a certain context, certain meaning associated with it. Our client thought completely different. So there was a dissonance in what it means. Again, what I'm trying to refer to here is what you think or what you believe is an emotion around it is how do you call it? That's your viewpoint about a certain attribute around a certain brand. What you see here is a result of a n-fold or let's say a voting done by people like taggers. But having said that, finally, what I'm trying to say is that the more simply kind of predicting what it has been trained on. So if the taggers thought that new mom is positive, it will predict positive. If new mom is neutral, it will predict neutral. So right, finally, it's learning from the data set that's been trained on. So again, your opinion. So as an individual, I'm not saying that your opinion is wrong. What I'm saying is all of us have opinion which is subjective in nature.
All right. Uh, Prashant, the next question is by Mandeep, who's saying, kindly advise if AI can be used in Indian aviation slash airlines slash airport service provider, air cargo operator, or customer baggage handling in conjunction with IoT.
That's a very broad question. The answer is yes to most of this. What I would say is that you will have to narrow down the use cases based on the kind of data that you have available. Let's say you have IoT data, you have so now customer service for example is one area you can definitely handle. In aviation, for example, dynamic pricing is happening as of now while you are speaking, which is an implementation of AI. So again, you will have to now look at what is the exact problem you want to solve, and then it's a matter of ROI. How easy it is to build a solution using data that you have, and what is the value add you will have if you solve that problem.
All right. Vijay has a question for you. He's saying, can you say some more examples or insights on real-time prediction using ML and big data?
Ankita, can you repeat that question?
For sure. Can you say some more examples or insights on real-time prediction using ML and big data?
Sure thing. So I'll give you an example where I actually worked on. And the idea is, let's imagine that you own Flipkart. Now, as an owner of Flipkart, there are millions of customers visiting your website, and they have their own unique digital journey happening, and you're collecting their footprints, which web page the customer went on, which links they clicked, which products they hovered on. So this all data is being generated in real time, and you have access to this data. Now, what you want to do is that, let me put it this way, you have a certain set of customer service agents available to you at any moment of time, let's say 100. Now, what you want, these customer service agents, each of this agent can handle, let's say, the three customer chats parallelly, which is concurrency in the industry, called as concurrency. Now, with that, so you have about 300 chats that can happen at any moment of time. You want to maximize two things. One thing is the acceptance rate of customers who are visiting the website of a chat offer. Second thing is, given that I can maximize the acceptance rate of a using machine learning, I still do not want to simply offer chat to anybody who I know will take a chat if I offer. I now want to filter it down by saying that I want to offer a chat to a customer who has a high propensity to accept a chat, but who also has a high propensity to convert and buy a product, given that I offer him a chat. So to make such models using real-time data is still one of the cutting edge works in machine learning. So you have about, so I mean, at least I know the project I worked on or the product we made, we had about 2000 different attributes getting updated in real time for each customer that is online. So to handle that data requires significant amount of engineering along with advanced data science work.
All
Question.
right. Okay. Shall I pick the next question, Prashant?
Go ahead, Ankita.
Yeah. So, what is your opinion on automated ML? How much market will it capture in coming months?
It's still something that's pretty new kid in the block, so I would rather reserve my opinion. And I think, as with any new technology, I think it's still, I would say it's too early to start making predictions about whether this is going to catch up or catch on or not. We have to
Hmm.
see some interesting high impact case studies to come out before we can start making those kinds of predictions.
All right. Let's move on to the next question. In which domains, industry do you feel AI has least penetrated, and why do you say so?
So I think here the answer is pretty obvious. So the more your business is high tech and tech oriented, the more the chance that you would be an early adopter of AI. So for example, Google, Amazon, I mean, it doesn't take a rocket scientist to guess that some of the best people in AI are working for them to create the next generation of AI based solutions. Having said that, now the more your business belongs to one of these old bricks and mortar kind of the conventional business, the higher the chance that your adoption is not really up to scale. So, for example, uh, one I would say uh, anomaly here is the CPG industry, which, given that it comes from the traditional industry world, is actually pretty mature in terms of the adoption of AI. But if you think about small to medium scale businesses in the conventional domain, that's where you can find a lot of interesting and high impact use cases. There, the challenge lies not in the application of AI, but they have not yet realized the importance of data to start collecting it at scale. That would be my answer.
All right, Prashant. The next question is by Rahul, who is asking, can we use algorithm to identify certain triggers in order to preempt abandon rate in BPO slash ITES arena?
Absolutely. We have actually done it before.
All right. There are few more questions, but I think this one we should consider it as a last one, keeping the time constraint in mind. So the last question for this session is, in diaper case study, how 22 attributes were fixed lookup or domain expert after fixing 22 attributes, how new attributes slash aspects were discovered and taken into consideration. Example, diaper feels soft here feels is somewhat pointing to material of diaper. That's a long question by Sachin.
I actually couldn't get that question, but I think what is being asked here is why 22, or how did we narrow it down to 22, and can how are we going to add new attributes? Is if I get that question correctly. At least I'll try to answer that.
Mm-hmm.
Why two? There's no clear reason for that. I mean, see, it's these. So this was a business decision, stakeholder decision that I need to know these 22 attributes. So there were about 18 that came up then. So the client approached us with about 18 different attributes that they wanted to get an understanding on based on our initial discussions. As it happens before you start any project, that list expanded to 22 and worked on with those 22. Can we do it with the new set of another 10? Yes, of course we can, but they do not simply come out of any magical hat. I mean, what? So, okay, maybe now I see another angle of this question. Can we identify new attributes from the data? Yes, we can. For this study, we started with a static list of attributes, and we are simply interested in those. That would be my answer.
All right. With this, Prashant, thank you so much for this lovely session. It was amazing to hear the facts and insights shared by you and how AI is transforming the future, how big data could be leveraged, and how to make data-driven decisions. It was an amazing presentation. Thank you so much, Prashant.
Thank you, Ankita. Pleasure was
Yeah,
mine. Everyone for
thank you.
listening.
Thank you. And to all the folks based out of Delhi NCR, an interesting workshop on 2nd of April is organized in Gurgaon on the topic how to build a global technology company. To register, please visit nascom.in/events for more information. See you guys with another session on product management on 11th of April. See you and thank you, Prashant. Thank you for your time and effort.
Thank you, Ankita. Thanks everyone for
Thank
attending.
you.
Bye bye.
Thank you. Bye, all of you.